fiction writer and queer quorum singer. Kevin Barrett and Sloane Perrault joined forces to develop sync and collaboration for the Obsidian platform, letting us map notes and idea into collaborative knowledge. In the way to this, they encounter an old friend of the beam, CRDTs. Let's give a warm welcome to Sloane and Kevin.
So really quick, as a show of hands, is anyone here familiar with Obsidian, the local first markdown tool? Like a handful of people, okay. For those who aren't, it's an incredible note-taking tool for building a kind of wiki-like thing from plain markdown notes. And for both of us, it was the latest stop in a long journey around note-taking. So here is a rough timeline of our experience taking notes. This kind of spider-looking thing, it's an amalgamation of us both. We've been taking notes on our devices for almost 20 years. Speaking for myself, every 2 years or so, I would light whatever I was using to take notes on fire and move to something new. I had no idea what I was looking for. I'm a novelist. I take a lot of notes. Every system I found had sharp edges. They didn't sync properly. They used a proprietary text format. They didn't work on my phone. It got to the point where I was better at moving between notes apps than taking notes. I wrote an exporter for Ulysses.app. I ran a custom NV alt fork. I took notes in voice recordings. I tried incredibly writing down notes on paper. Nothing worked, and I just kept changing. Then I found Obsidian, and it was nearly perfect. I can take notes in Markdown, a format that's probably going to outlive me. I can write my own plugins. I can customize how the app works. I can theme it. I got comfy. And then in about 2 years, I got uncomfy. I wanted to change systems again. I started looking at new notes apps the way my dad started looking at model train catalogs when he turned 40. And I stopped myself in this moment, and I said, what do I really want here? What are the sharp edges? All of my needs were met except one. Anywhere I worked as a programmer, I was being forced to use Notion or Google Docs or Confluence to collaborate. I'd write a beautiful note, and then I would chuck it in a black hole from which it would never escape because no one ever read notes there, because no one took notes there. I wanted my shared and my personal notes to live alongside each other. And this was true for side projects as well. I would write a novel, and I'd want to share a scene, and I have to copy and paste the markdown to send it to someone. What I really wanted was to somehow stay in flat markdown files while being able to collaborate and share and edit on the web.
So Kevin told me a much abridged version of this story. He said something like, I wish I had Google Docs, but in Markdown. So over a weekend, I built a prototype of exactly that, and I sent a video of it to him, and his mind was blown.
I was stunned. Sloane and I could work on docs alongside each other next to our private notes. That was 2 years ago, and since then we've drawn the rest of the owl. But I remember asking her, how did this all work? And she responded with an initialism I'd never heard before.
CRDTs, or conflict-free replicated data types. We'll cover how we've used them in screen.garden in a minute, and specifically how we ended up using them to push business logic from the server to client applications. But first, let's go over what they actually are. Quick caveat with CRDTs, we're now really truly entering the PhD zone. CRDTs are the subject of active research labs as much as they are production-ready tool sets. We can give an overview of what they are and how they work, but there are lots of excellent resources you can use to dig deeper. We'll have a slide of those resources later on. All right, conflict-free replicated data types. It's one of those terms that piece by piece explains itself. But let's get there by example. Assume you're trying to build a random example here, a distributed note-taking service. You have lots of users who may or may not be connected to the internet, and they should all be able to update notes independently. When they connect to the internet or to each other, they should be able to merge those changes without conflict. That last bit is really important. One possible way to do this is with something like a version control system, like Git. Git will attempt to resolve a series of interleaved changes, a merge or a rebase, but it's allowed to throw up its hands and declare that there's a conflict. And at that point, a human has to intervene and tell the machine how to resolve that conflict. As its name implies, a CRDT is by definition conflict-free. It must define a merge mechanism that cannot result in a conflict. Git can do this sometimes, but a CRDT has to do it no matter what. A simple way to show these conflict-free merges is with the CRDT counter. It works like this. Everyone gets their own copy of a counter starting at 0. You can increment your counter, and when you do, you maintain a log of each increment. These are transactions. When it comes time to merge our counters together, we send up all of our individual increments. We define the merge policy as simply adding all of those transactions together. And because addition is both associative and commutative, the order of operations don't matter. So addition is 100% conflict-free. Once we've seen the same transactions, regardless of the order that we've seen them in, we always end up with the same result. This is a really contrived example, but the principle is the same for all CRDTs. They avoid conflicts by the nature of how they merge changes.
The other relevant bit of a CRDT is that it is replicated. So everyone got their own copy of the counter, just like how in Screen Garden, everyone gets their own copy of the note. If we port our incredibly contrived counter example back to a traditional architecture, we can see there are some inherent behaviors that arise from keeping your state in a database. There's a single source of truth. You have to connect to that sort of source of truth at some point in time to mutate it. And because we have an ACID database and require a connection, those mutations are inherently ordered. Going back to CRDTs, there are different implied behaviors. The copies are all equally valid. They're all the source of truth. So in a system built on CRDTs, there doesn't even need to be a server involved if you don't want there to be. Mutations can happen offline. There's no inherent ordering. If there's enough copies of one in circulation, I might not even see every copy. I would instead see a merged version of one. So kind of as an example, if we each had a copy of that counter CRDT here at Codebeam, we could kind of carry it with us. And every time we talk to someone, we merge them. And at the end of the conference, there would be a single counter with value equal to the number of attendees. It gets more complicated when we start talking about plain text notes. And those PhDs you mentioned have done the work of actually figuring out how to merge text without conflict. And I cannot pretend to explain how it works in detail, but at a high level, there are kind of these production-ready CRDTs that have clocks that track data type state over time, and those clocks resolve conflicts. CRDTs are a new technology. How they work will almost certainly change and become more efficient over time. Here's a list of researchers and technologists we highly recommend following if you're interested in CRDT internals and the research around them. If you've used Horde for distributed supervision, you've actually already used a CRDT because it uses the Delta CRDT, which is Elixir native. And if you've used Phoenix Presence, you've also used a CRDT. So that's our gloss on CRDTs and how they work. Going forward, we can kind of assume we have a binary blob, we can pass it around, we can replicate it as we see fit, merge without conflict, it will be eventually consistent. So the real question, the kind of the purpose of this talk is, what can we do with it? So my first pitch to Sloane for Screen Garden was shared notes. That's what we built. We used a CRDT called YJS, which is a JavaScript CRDT, but it has a Rust implementation called YRS, or wires. We wrapped this in a Rustler-NIF. There's now a public wrapper like ours called Y_EX. That's worth looking at if you want to do this. Wires provides a plain text CRDT type, and that's what we use to represent markdown notes. Two users on two different machines could edit the same note, and their clients would send updates to our Phoenix server, and the server had its own copy of the CRDT, and it would broadcast those changes back down.
So instead of storing each note as a text column or something in a relational database, state was now spread across our server as well as each client. More specifically, we used Phoenix channels to handle all of this coordination and message passing. Wires requires checking out a transaction for any operation against the CRDT, and attempting to check out a transaction if one is already checked out will cause a panic. Luckily, the Beam has a perfect solution for this, and that's processes. We wrapped all of our servers' copies of the CRDTs in gen server processes, and we'll return to this a little later, but it ends up being a really powerful concept. The way that the Beam handles parallelism makes reasoning about CRDTs much easier than in other ecosystems. Process isolation provides a natural interface over the data. Coupled with Phoenix, we were able to treat our server like any other connected client, gossiping about data changes with other clients. We're confident we couldn't have spun up a system like this as quickly and efficiently in any other ecosystem.
So about a year ago, we had Screen Garden 1.0, notes as CRDTs that you could share individually with other people on the web and in Obsidian. And I feel like an Apple executive saying this, but it felt like magic. And then we launched it, and we had gotten the problem totally wrong. People wanted to share folders of notes, and they didn't know what to do with this, and we were just wrong.
So yeah, we realized that people didn't want to share individual notes. They wanted to share folders of notes and have it all automatically sync. After all, we're building an integration with Obsidian where notes are linked together. We should be able to handle this sort of thing. And we had a CRDT library in the app already, which is a very big hammer. It can't be that hard, right? We'll zoom out another layer of abstraction and model the folder tree as a CRDT itself. YJS provides a map type. We can use paths as keys, and the values will be pointers into our old note CRDTs. Creating, moving, and deleting files are just edits of that map, and we're done. We solved it in 30 seconds. We did it over a year ago, and then we played Balatro until we shipped. Not really, obviously. We spent the past year working through all of the trade-offs and weird edge cases and knock-on effects from effectively putting a large portion of our data model into a client-side blob. Shifting logic from your server isn't something you should do lightly. Here's a list of some of the bigger problems we worked through, so let's go through them one by one. CRDTs aren't a native database type. Once you decide to move blobs of data into a CRDT, you're signing up how to make that information indexable and searchable in the future. You can certainly store them in Postgres as binary blobs, but they're not necessarily plain text, and they can be quite large. So you need to be aware of the cost of storing them in a column. You may even want to store them outside the database or in some other more novel format. This is called foreshadowing.
CRDTs may not handle authorization. So most off-the-shelf CRDTs, like the one that we used, they concern themselves with the bits we've talked about, providing a way to exchange data without conflict. And that doesn't necessarily include authorization or even the identification of actors who are making changes. So if your system has requirements such that certain people can modify certain CRDTs in certain ways, you probably need to layer that over the CRDT. And we should note there is some research into doing this inside a CRDT. There's specifically a CRDT called AutoMerge made by that lab, Ink and Switch we mentioned earlier, and they bake role-based access into the CRDT itself, which is super exciting. But odds are, right now, you have to do this yourself.
Related to authorization, CRDTs are really just blobs. We've said this before. And because of the way we update them, feeling transactional and mediated, it's really easy to think of them as structured and self-validating, but they're not. Anyone with access to the CRDT can mutate it, and it's on you to make sure that that doesn't break your system. For example, in Screen Garden, we have extra checks in the server to make sure that a client can't arbitrarily insert someone else's note into their own folder. They could edit the folder CRDT, but they're going to be denied access to that note.
So because CRDTs are conflict-free, they're a great fit for peer-to-peer applications. And it can be very, very tempting to drop peer-to-peer into your system when using a CRDT. Sometimes this is a great fit, but it also adds a new dimension of application surface area to consider. So as an example, assume you have two users who have two copies of the same CRDT, but they're never online at the same time, so they can never exchange edits. So you need something in the middle to pass those edits back and forth. But once you have that thing in the middle, you now have to layer on trust, which you didn't have to do before.
All right. We're in the middle of our list of extra considerations. And I want to say that we really do like CRDTs, and we promise they're worth it in plenty of cases. You just have to be careful. OK, onward.
So again, they're just blobs. That means if you're mutating them on the server, you're doing so in memory, and they can get pretty big. So make sure your server is prepared for this kind of bursting. You can cluster. You can also pool access to the CRDTs. And some of them allow for tunable garbage collection, so you can reduce edit history and thus size. You can also get clever with primitives like object storage to get CRDT-style versioning without actually keeping edit history. And this is also foreshadowing.
If you're working with Phoenix, then you already have access to Phoenix's own CRDT, presence. Some CRDTs, including YJS, have presence-style APIs where you can encode real-time user state into the CRDT itself alongside your other data. This can be very useful for stuff like live cursors, where you want the character indexes to match the text in the CRDT. But using those APIs means you have all the drawbacks that we already mentioned, like being opaque and not easily searched. You can use presence instead, but if you store information about another CRDT in presence, then you have to account for the information in presence being either slightly ahead of or behind the actual CRDT state. If you can solve that, presence is great when used with other CRDTs. We use it in Screen Garden to do live cursors and more traditional presence so that anyone on a team can see where in their notes their teammates are working. It feels pretty amazing.
All right, last drawback slide, and then we get to the non-drawbacks. This one needs a bit of explaining. It's really, really easy once you've shifted some data into a CRDT to keep shifting more data into a CRDT. So another example, let's say you're using a CRDT to map a user-editable corkboard. So there's cards on a board, and everyone can move them around and edit them. And now you want to add a trash can. So if I delete a card, it's a soft delete. It goes into the trash can. Maybe eventually I can restore it. So you're like, OK, great. I add a new field to the CRDT. That's like the trash field. And when I delete a card, we jam it into the trash field. Amazing. You now have a synced trash can. That's great. You also now have data in your CRDT that's not in your database anymore. So you have to think about that. It's very easy to expand a CRDT and very hard to shrink it. Every time you expand it, you should think about the trade-offs involved. And scientists cannot confirm or deny if the universe revolves around a CRDT.
So those are all the gotchas that we could quickly rattle off. Now let's dig a little bit deeper into what a full-fledged CRDT-based architecture might look like and what advantages it has over a more traditional system, using what we built for Screen Garden as an example. Remember, the problem that we needed to solve was modeling Dropbox-style sync of a recursive directory of Markdown nodes. Our CRDT library, YJS, provides as available primitives a text type and a map type, among some others. As a vocab note going forward, every time we say doc here, we mean an instance of a CRDT. This is more precise terminology, and honestly, I've said CRDT enough times already. For Screen Garden, we knew we wanted to model recursive directory structures with text nodes as leaf nodes. Nodes are solved fairly easily with the YJS text type. For directories, we introduced a second doc and called it a collection. The core of a collection is two maps of string paths to note UUIDs. CRDT maps are quite nice as their diffs are fairly CRUD-like in appearance. They have key insertions and deletions, value changes, etc. Note and file operations can happen online or offline, so we have clients mint their own UUIDs. Inserting a note into a collection is just minting a UUID and inserting the path key to a new UUID value. There are weird drawbacks too. If there's one thing you should take away from this talk, it's that CRDTs are not free abstractions. In our case, the title of a note is the final path component, and paths now live in that collection doc. This means that if we want to display a note's title alongside its content, we have to read both the collection and the note docs into memory.
So that's how collection docs are laid out, maps of paths to node IDs. On the server side, we decided to mirror every replicated connected doc with a channel. And this was initially a decision of convenience, but it ended up having really incredible knock-on effects for our architecture. The core insight we stumbled onto here is that if you leverage the beam to map docs to processes, many of those caveats that we kind of laboriously listed out earlier fall away. You have implicit operation ordering, you have a source of authority, you can address your docs from anywhere in your application, including like live views. So to show this, we're gonna consider the moment a client joins a collection doc to a channel. And in this talk, we're calling this a moment of control. This is not a technical term, it's just what we're calling this to say, great, we have this moment to impose centralized authority. So we have a collection doc here. It has a few notes in it. We mentioned earlier, collection's really two maps. It's a map of notes that all clients agree this is in the collection. And then it's a map of pending notes that are maybe local to a single client. The server's yet to bless it. So we're gonna assume we're on an airplane, we have not connected to a server, and we add a new note. So we insert the note into the pending map. And to do this, we mint a UUID and a path. We insert that into the map. This is all local to the client. A client can do this 1,000 times if you drag and drop a folder into Screen Garden. From our perspective, it's all the same. Then our airplane lands, and we connect to the server. And our collection and note docs both attempt to join channels. So the collection join succeeds. We're going to assume that the user was authenticated. We're going to assume the collection already existed. We handle those as other cases. And the mutation that's in the client-side doc hits the server and is resolved against the server's doc. The note channel join is a little weirder, and here's really where the control comes in. So when the note join request goes up, it carries the note ID and the collection ID corresponding to that note. We project all of our notes into the database as a kind of authorization layer. So when the note join happens, it takes the collection join in the node ID and it says, does this node exist? Have we seen this before? We know, no, this is a new note. So we read the collection into memory and we say, is this a pending note? And we say, yes, this has just got added to the pending map. So then we say, okay, great, we're gonna promote this note. We're going to update the collection doc and move it from pending to the kind of blessed, this is actually a note map. We're gonna insert that note into our database, so it's now, there's an authorization component to this. And this is also our chance to do additional control, so we can check for path collisions, we can do renaming. This is really our moment to have a centralized voice. Once this promotion dance is over, the note join finally succeeds, the collection promotions mutation is sent back down to clients, and anyone who comes by later, they see there's a new note and they request to download it. So this whole dance, in our opinion, really shows the core advantage of using the beam with CRDTs. You can model what is fundamentally a distributed data type inside a fundamentally distributed system. And as a result, you have a really fine-grained control over when a server exercises authority. Processes can do authorization, they can project docs in the database, they can selectively reject updates. The beam makes this very simple.
And once you have this set up, you get to pull in the rest of the power of the beam ecosystem too. Although CRDTs contain their edit history, we instead build a system of message logging and rollups to save off versioned blobs using OBON and object storage. This means the docs that we send between server and clients are more tightly garbage collected, and we get to lean on a more traditional server solution for that blob versioning. You get the power of Phoenix too. We couldn't really believe it was this easy, but we shipped a web editor that's connected to Obsidian as a kind of side effect of doing all of this other work. LiveView meant that we could sync docs to a web front end with a couple lines of code, and mounting the editor largely reused the same code we use in our Obsidian plugin. This started out as a test tool, and it really became a banner feature. So that's an overview of what we've learned by banging our heads against CRDTs for the past couple of years. We truly believe that they unlock genuinely new applications and architectures within the beam and would encourage you to try them out. And if you're interested, you can also try out screen.garden at screen.garden. I think we have just a couple minutes for questions.
Yes.
You talked about the garbage collection abilities. Have you ever modeled one of your collections going viral to the point where, like, I guess what's the latency between a bunch of clients joining with additions or pending and your ability to garbage collect those blobs down to a more meaningful size? And is that a potential accidental DOS or intentional DOS?
Sure. So currently, like, our pricing model is based on how many people you have, like, in your team. You can't really have a collection public to everyone. So like there's a natural limitation to sort of the virality, like you mentioned, of like collections or notes. There's definitely something to consider there, like going forward, if we add like anonymous contributors or something via link, like that's something we'll need to do. There are portions of the system, Kevin mentioned like pooling. We maintain these things in memory, and so we maintain like a max limit of how many of those we have at a given time. So a lot of them would, like if we get very popular and we need to spread out over more nodes, there'll be a point in time where we have just like some thrashing basically in that pool.
I would add, like, we have done pretty informal testing of pushing up of like 10 to 20,000 notes at once, and it just churns through it. The NIF is pretty good at just being pretty quick at this.
Okay, and I think one more question, and
thanks, really interesting stuff. I was just trying to wrap my head around the way in which you're using a CRDT in the client, but then you, in a sense, have a server or authoritative system where you're saying you're sort of having like an actor, like a gen server, kind of managing the updates for a CRDT, and then you're writing through the relational database, and then the changes are coming out, and you're syncing those back into the clients, kind of into where they would be into the CRDT. Are you syncing? Is it operation-based CRDTs? Are you syncing the operations Are you doing any kind of, I was just sort of trying to understand what that loop was of what are you actually sort of saving, what's managed by the actor, what are you storing into the database, and then do you actually need CRDTs when you have the server authoritative component,
Yeah,
or does sort of mapping it to channels kind of get rid of the need for that?
I can take it, or if you want to.
How about I'll start and then you can. So so yeah, we're pushing up and down updates, which is a kind of format that YJS gives us. So it's kind of like a wrapped transaction. We're writing back. It's kind of write ahead log idea. We're writing those updates and then rolling them up into the final CRDT. We don't technically need one in the sense that we could be using operational transforms or something and achieve the same effect. There are advantages to using one in our case anyway, which is that we have this kind of built-in integration on the client. Someone could be offline for like 2 months building up their series of changes, and it would be it would be less trivial to do that with operational transforms than just kind of do the normal merge and push that all together.
Yeah, there's a piece that we didn't have an opportunity to really dig into that is the CRDTs can also diff against each other. And so that's, like with operational transform, we might have to maintain this very large log or something if someone's offline when they come back online to send that up. Our system will send, there are state vectors, which are representations of those clocks. A connecting client sends that up. Our server can tell what pieces of the CRDT they're missing based on their state vector, and there's this sort of sync dance that happens. That happens as well as like an immediate rebroadcasting of incoming updates to other clients. So we have the ability to have like full end-to-end sync, but also have like quick, low latency like collaboration too.
Yeah, makes sense. So in a sense, it's sort of mainly transport for the operations, but also some clever stuff on top of that.
Yeah, it's important to us to like Obsidian really is like the source of truth in this case, right? Or the markdown is, right? You can think of it as like a projection of the CRDT, but it also like it's a first-class citizen of this system, and so we want to maintain that.
Yeah, I think we have to wrap up. But if anyone has any other questions, feel free to find us in the hallways. We'd love to chat about it more.
Round of applause.
Thank you.